Data analysis. Module 1 Introduction to data analysis and its applications. Topics to be covered. Introduction. Methods. Statistics. Models. Softwares. Introduction. Due to modernization, organizations are bigger than ever. As such, the quantity of data circulating around it is absolutely massive. Retailers collect point-of-sale data on products and customers every time a transaction occurs. Credit agencies have all sorts of data on people who have or would like to obtain credit. Investment companies have a limitless supply of data on the historical patterns of stocks, bonds, and other securities. And government agencies have data on economic trends, the environment, social welfare, consumer product safety, and virtually everything else imaginable. Technology has made it relatively easy to collect the data. As a result, data are plentiful. However, as many organizations are now beginning to discover, it is quite a challenge to make sense of all the data they have collected. Thanks to the advancement of technology, we now have powerful personal computers, cheap and readily available software with user-friendly interfaces and training programs that educate people on how to use said technology. With this power, a single person can now perform tasks which would once take an entire sector weeks to perform in mere days. Nowadays, there are dedicated subjects for quantitative analysis, in order to teach people to use the tools at their disposal and process this large amount of data. The amount of data an organization can have at any given moment is huge. That amount will only continue to rise in the future. A successful company will dedicate resources into processing that data into information and will excel in the market. Methods. Data analysis is a technique that typically involves multiple activities such as gathering, cleaning, and organizing the data. These processes, which usually include data analysis software, are necessary to prepare the data for business purposes. Data analysis is also known as data analytics, described as the science of analyzing raw data to draw informed conclusions based on the data. Data comes in different structures, formats, and types, including the following. Big data. Big data is defined as a huge data set that continues to grow at an exponential rate over time. The four fundamental characteristics of big data are volume, variety, velocity, and variability. Volume describes quantity, velocity refers to the speed of data growth, and variety indicates different data sources. Veracity speaks to the quality of the data, determining if it provides business value or not. Structured, unstructured data. Structured data is a predefined data model such as a traditional row-column database. Unstructured data comes in a format that does not fit in rows and columns and can include videos, photos, audio, text, and more. A comparison of structured data versus unstructured data reveals that structured data is easier to manage and analyze. Metadata. Metadata is a form of data that describes and provides information about other data. For example, metadata for an image can include the author, image type, and date created. Metadata enables users to organize unstructured data into categories, making it easier to work with. Real-time data. Data that is presented as soon as it is acquired is known as real-time data. This type of data is useful when decisions require up-to-the-minute information. For example, a stockbroker can use a stock market ticker to track the most active stocks in real time. Machine data. Thanks to the Internet of Things, IoT, sensors, and other technologies, data can be automatically generated by factory systems and other machines, information technology and telecommunications infrastructure, smart cars, handheld devices, and more. This type of data is known as machine data because it is produced wholly by machines without human instruction. Data analysis methods and techniques are useful for finding insights in data, such as metrics, facts, and figures. The two primary methods for data analysis are qualitative data analysis techniques and quantitative data analysis techniques. These data analysis techniques can be used independently or in combination with the other to help business leaders and decision-makers acquire business insights from different data types. Quantitative data analysis. Quantitative data analysis involves working with numerical variables, including statistics, percentages, calculations, measurements, and other data, as the nature of quantitative data is numerical. Quantitative data analysis techniques typically include working with algorithms, mathematical analysis tools, and software to manipulate data and uncover insights that reveal the business value. For example, a financial data analyst can change one or more variables on a company's Excel balance sheet to project their employer's future financial performance. Quantitative data analysis can also be used to assess market data to help a company set a competitive price for its new product. Qualitative data analysis. Qualitative data describes information that is typically non-numerical. The qualitative data analysis approach involves working with unique identifiers, such as labels and properties, and categorical variables, such as statistics, percentages, and measurements. A data analyst may use first-hand or participant observation approaches, conduct interviews, run focus groups, or review documents and artifacts in qualitative data analysis. Qualitative data analysis can be used in various business processes. For example, qualitative data analysis techniques are often part of the software development process. Software testers record bugs, ranging from functional errors to spelling mistakes, to determine bug severity on a predetermined scale, from critical to low. When collected, this data provides information that can help improve the final product. Statistics. Statistical analysis is the collection and interpretation of data in order to uncover patterns and trends. It is a component of data analytics. Statistics deal in numbers and is the heart of quantitative analysis. Statistical analysis can be used in situations like gathering research interpretations, statistical modeling, or designing surveys and studies. It can also be useful for business intelligence organizations that have to work with large data volumes. In the context of business intelligence, statistical analysis involves collecting and scrutinizing every data sample in a set of items from which samples can be drawn. A sample, in statistics, is a representative selection drawn from a total population. The goal of statistical analysis is to identify trends. With the numerical values, graphs and models are crafted, then using simulations and extrapolation a relatively likely future scenario is predicted. A retail business, for example, might use statistical analysis to find patterns in unstructured and semi-structured customer data that can be used to create a more positive customer experience and increase sales. Steps of statistical analysis. Statistical analysis can be broken down into 5 discrete steps, as follows. Describe the nature of the data to be analyzed. Explore the relation of the data to the underlying population. Create a model to summarize an understanding of how the data relates to the underlying population. Prove, or disprove, the validity of the model. Employ predictive analytics to run scenarios that will help guide future actions. Models. Statistical modeling refers to the data science process of applying statistical analysis to datasets. A statistical model is a mathematical relationship between one or more random variables and other non-random variables. The application of statistical modeling to raw data helps data scientists approach data analysis in a strategic manner, providing intuitive visualizations that aid in identifying relationships between variables and making predictions. The first step in developing a statistical model is gathering data, which may be sourced from spreadsheets, databases, data lakes, or the cloud. The most common statistical modeling methods for analyzing this data are categorized as either supervised learning or unsupervised learning. Some popular statistical model examples include logistic regression, time series, clustering, and decision trees. There are 3 main types of statistical models: parametric, nonparametric, and semiparametric. Parametric, a family of probability distributions that has a finite number of parameters. Nonparametric, models in which the number and nature of the parameters are flexible and not fixed in advance. Semiparametric, the parameter has both a finite dimensional component, parametric, and an infinite dimensional component, nonparametric. Software. There are abundant tools for data analysis nowadays. A simple Google search of data analysis tools will show no less than several million results, all of which will display lists with countless applications. Let's start with the basics. The 2 most simple tools to begin with are Microsoft PowerPoint and Microsoft Excel. These are the bare minimum of apps to log and display data, and ever since their development in 1985, they are still some of the most frequently used applications to date. Summary. Once we have finished this module, we should have learned about the basics of data analysis, learned about the methods of data analysis, learned about statistics and models used in data analysis, learned about the software used for data analysis.